Welcome to the Explainer. Let's jump right in, because today we are tackling one of the single most frustrating hurdles in the world of artificial intelligence. Look, if you've ever used a large language model and caught it just confidently making up facts, a phenomenon we all know as hallucinating, you know exactly what I mean. Well, today we're going to uncover how a truly groundbreaking architecture called Retrieval-Augmented Generation, or RAG, actually solves this critical flaw of standard LLMs, making AI accurate, secure, and completely verifiable. Here is our roadmap for today. We're going to start with Section 1, the problem with LLMs, then move into 2, meet RAG, the solution. Next, we'll compare 3, RAG versus fine-tuning, trace 4, the evolution of RAG, take a look at 5, optimizing the retrieval process, and finally peek into 6, the future of RAG. Let's get to it.
All right, Section 1, the problem with LLMs and why standard models fail.
It's a pretty fascinating question, right? Why does an otherwise brilliant model confidently state entirely incorrect facts when it's taking a closed-book test? Think of a standard large language model like a really smart student who memorized a massive amount of information a year ago. If you ask it a highly specific, recent, or super niche question about your company, it doesn't have the text right in front of it. And crucially, it isn't really programmed to just say, hey, I don't know. Instead, it falls back on its internal mathematical parameters to predict the next most likely word based on frozen, outdated training data. It's not lying maliciously, it's simply guessing. And that often results in a highly articulate, very confident, total fabrication. As we can see broken down here, there are 2 main types of hallucinations we deal with. First, you have factual hallucinations. This is where the AI literally invents history out of thin air, like claiming Charles Lindbergh was the first man on the moon just because it mathematically conflated aviation pioneers. Then you have faithfulness hallucinations. This happens when the model is actually given the correct context, but it completely misinterprets or contradicts that source material in its final answer. The research shows these errors pop up because of flawed training data sources, misalignments during that initial training phase, or just the inherent randomness baked right into the inference decoding strategies. Now, this guessing game, it's totally unacceptable for real-world business applications. Enterprises have strict, non-negotiable requirements. They absolutely need domain-specific accuracy. I mean, imagine an AI giving a customer incorrect legal advice. A business needs traceability to see exactly which internal document an answer came from. They also need frequent knowledge updates without waiting months and spending millions to train a brand new model from scratch. Add in the need to control compute costs and ensure absolute privacy protection for proprietary data, and it becomes pretty clear why standard static LLMs simply cannot cut it as a reliable enterprise solution. Which brings us to Section 2, meet RAG, the solution, the open book test for AI. So let's talk about this massive paradigm shift. Retrieval-Augmented Generation, or RAG, seamlessly combines the raw strengths of traditional information retrieval systems, think high-powered search engines, with the generative capabilities of modern LLMs. Instead of relying on what the AI memorized months or years ago, RAG acts as a real-time bridge directly to your secure external knowledge base. It essentially hands the AI an open book test, forcing it to look up the correct, secure information before it ever tries to synthesize a response. Check out how this flows. When you process a query with RAG, the application doesn't just blindly send your question over to the large language model. First, a retrieval mechanism searches through an external database, pulling highly relevant chunks of documents. It then bundles your original question together with those retrieved verifiable facts and hands the whole package to the LLM. The AI then synthesizes its answer based purely on that strictly provided context. This completely grounds the final answer in your private data. And the best part? You never even have to alter the core model itself. Moving right along to Section 3, RAG versus fine-tuning, and choosing the right optimization. Now, this is a huge debate for developers. When do you use RAG, and when do you fine-tune? Fine-tuning permanently adjusts the internal neural weights of the model. It's kind of like teaching the AI a new language, a specific writing style, or your corporate tone. But as this comparison highlights, fine-tuning is honestly terrible for injecting new facts. RAG, on the other hand, is like handing the AI a new textbook. Because every single answer is explicitly grounded in retrieved evidence, RAG is inherently way less prone to hallucinations. Plus, RAG allows for immediate knowledge updates. If your company policy changes overnight, you just drop the new PDF into your database and boom, the RAG system instantly knows the new rules. No lengthy, expensive retraining required. All right, let's dive into Section 4, the evolution of RAG, from naive to modular. We start with the foundational architecture, what engineers actually call naive RAG. It's a pretty straightforward three-step pipeline. Step 1 is indexing. You divide your original massive documents into smaller chunks and convert them into mathematical embeddings. Think of embeddings as turning sentences into coordinates in a high-dimensional space, so similar concepts are physically grouped closer together. Step 2 is retrieval, using vector similarity search to find the coordinates or chunks most relevant to whatever the user asked. And step 3 is generation, passing those related text chunks alongside the prompt to the frozen LLM to get your final answer. But engineers quickly ran into a wall with this. Naive RAG often pulled in irrelevant, noisy data that just confused the language model. The fix? Advanced RAG. This architecture introduces absolutely crucial pre-retrieval routing and post-retrieval filtering. Pre-retrieval means doing fine-grained data cleaning and actively rewriting the user's prompt so the search engine understands it better. Post-retrieval means taking the chunks you found, re-ranking them by relevance, and filtering out the junk. This cleans up the context window and massively improves accuracy before the AI ever even sees the text. And that brings us to modular RAG, the cutting-edge paradigm we operate in right now. Instead of a rigid linear pipeline, independent modules can be dynamically organized into sophisticated loops and patterns. You have distinct modules to search, read, predict, or reflect. Take the rewrite, retrieve, read pattern, for example. If a user asks a vague question like, "How did revenues change?" the rewrite module kicks in first. It analyzes the chat history and rewrites the query to Q3 2023 versus Q4 2023 enterprise revenue. This ensures the retrieve module actually finds the right financial documents before the read module finally synthesizes the perfect, highly specific answer. Okay, Section 5, optimizing the retrieval process to make RAG even smarter. Building these sophisticated systems is a real balancing act. Engineers have to answer 3 key questions to perfectly balance processing efficiency with information depth. First, what to retrieve? Developers have to decide, do we pull coarse paragraph chunks or precise entities? Coarse chunks give you the surrounding context, but risk muddying the waters with irrelevant sentences. Precise entities give exact data points, but you might lose the broader meaning. Second, when to retrieve? Do you run a single upfront search, or do you use adaptive search, where the model dynamically decides it needs to go back to the database mid-sentence? And finally, how to actually use that retrieved information across the input, model, or prediction layers of the architecture. To really supercharge these setups, developers rely on 2 major optimization techniques. First up is query optimization. By actively rewriting ambiguous queries using a smaller, faster model before searching, we can perfectly match the specific vocabulary used in the stored documents. Second is embedding optimization. Look, a generic embedding model might completely miss your company's proprietary terminology or acronyms because it was just never trained on them. By fine-tuning the embedding models specifically to align with your domain's unique repositories, we stop the AI from missing highly specific data. This saves on compute costs and drastically improves the system's hit rates. Finally, Section 6, the future of RAG and expanding the ecosystem. The RAG ecosystem is absolutely exploding right now, pushing way beyond simple text-based question answering. It's expanding into diverse downstream tasks like dynamic code generation, real-time fact verification, and really complex agentic workflows. But what's even more exciting are the multimodal extensions. Imagine asking your company's AI not just to summarize a PDF, but to instantly pull up a specific timestamp from a recorded Zoom meeting, or to analyze an internal architectural diagram against a text-based safety manual. That is the multimodal future of RAG, pulling in rich media to provide the ultimate context to the language model. As enterprise applications explode in scale, modular RAG is no longer just some fringe experiment. It's the mainstream standard. So I want to leave you with this to consider. How will giving AI an open book, highly accurate, and secure memory completely reshape the way your business interacts with its private data? Because the era of AI simply guessing, that's ending. The era of verifiable, grounded AI is officially here. Thanks for joining us for this explainer, and we will see you next time.